Okay, but my moment now it goes, my force now it goes to this direction. P equal to, we have to set this 10 Newton. This one is 30 degree. Okay, so now we have the force P equal to 10 Newton. Same by the previous one. This is 2 meter. Why is moment feel by point A? Okay, why is the moment feel by point A in this case? Okay, so by definition, what you will do is you put the P, F times the D. So F equal to 10 Newton. So why is the D? D is perpendicular distance, or the shortest distance between this line of action of force toward this point. That is the shortest distance, which is, you have to find where it is 90 degrees. So this is 90 degree. Okay, so this is the D. Or always, normally I will use the method which is make this line, make second line parallel to this one, go through A. So we have this one, and this is the distance. You get the same thing. Okay, so our D here is now, this is our D. Perpendicular distance from the line of action of force towards the point A. So that is our D in this case. Okay, so you can calculate where is the D, because here of course you have, this is 30 degree. So this is 30. Okay, so this is 60 degree. So here is 30, so must be here is 60. Okay, and so on. Okay, so from here, this is 2. You want to take this is 90. So you want to take this this one. So you can maybe use this 60. You have the sine. Okay, 2 sine this one, sine 60, you get the D. Okay, and then you have the answer, D. Okay, so you put the D, which is here. Okay, and which direction? The direction is, you have this one, and you try to pull this one to up like this one, and it still have the tendency to move clockwise. Or you have this to upward, and then you want to go to here, so just go directly here. So you have the direction is clockwise. That is for moment. Okay, by definition, the D is the line, the distance 90 degree towards the line of action of force to the point when you take the moment. This is one way. You can do it other way, which is, okay, there is one way to solve. The other way is, if we are taking the same component here, point A, P equal to 10 Newton, 30 degree. Okay, so the first method is using directly the definition, which is force times the distance, which is the shorter distance between A and this line of action of force. The second one is, you can still instead of using directly the P, you know that we have learned from previous chapter, the P you can resolve into component that you want. Okay, so in this case we can resolve that using the component. The easiest one is to use the one, to make it one at the component which is parallel to this one. The other one is 90 degree to this force. So in this case, what we can do is, we can directly resolve this component into 2, which is 10 cos 30. The other one is 10 sin 30. So I can put away this one. Okay, so instead of having the 10 times the D as this distance, now your moment point A equal to F1 D1 plus F2 D2, because we have two forces. Okay, so and then once we have several forces, you need to consider the direction. Let's say we consider clockwise as a positive direction, because we consider if it is negative, we have to minus. So MA. So let's say this is F1. So 10 cos 30. The D, you make a line here, and this is the second line, 90 degree. This is the D, which is 2 time F2, which is 10 sin 30. Okay, so F1, put a pin here, pull this direction, it will turn clockwise. So I make it positive. This one, F2, 10 sin 30. You see from here, you pull upward, you will not have a rotational movement. So the force moment created by 10 sin 30, it will be 0. Or if you put in this equation 10 sin 30, you want to put the distance, which is, you make a line here from this force straight, you go directly to this point. So the distance here is 0. So you have the answer Newton meter positive, so this direction. Okay, so you have two methods. The first one, you directly use that force. Okay, use that force and then find the distance, or you can resolve into two components, one which is perpendicular, the other one is 90 degree. Two components, the one will go directly to the point and the other one will go 90 degree to the line, and then you can calculate the forces. Okay, you can resolve in this way. It is easier for you to find the D, because you can directly find which is 2 here. The other one will be directly 0. From here, the benefit is you don't have to resolve. You just find the D. So it's plus and minus. So you can, it's up to you which one you want to use. Okay. If you think that from here it is difficult for you to find the distance, use that method. Okay, because you know directly how to resolve into X and Y. Okay, so you just resolve, and easier for you to find the distance. Okay. Okay, so let's see this one. What happens if we have one rigid body, but we have several forces acting on that rigid body? Okay, so the question is, what is the moment about point A because of all these forces? Okay, so the way is we have to treat it one by one and add up together, and we have to put the direction, and then we add up together, we will have the moment. So what we will do is, we will calculate the moment of point A because of force 1 plus moment at point A because F2 plus moment at point A because of F3 plus moment at point A because F, we have 4, we don't have 4 for that one. 4, okay, plus moment of point A because of F5. This is not times F1, F2 and so on. This is because of F4, F5 and so on. Okay, you can do it that way, or you can also do it as moment A equal to, you make the sum of this force first, sigma F times the D. Okay, but this way you have to find first what is the sum of force, and later on you calculate. But normally I will use directly this one. Okay, you calculate the moment because of each and individual forces. Okay, but because of we know that each moment we will have the direction, some clockwise and some others will be counterclockwise. So we have to choose which direction we consider positive and what direction is negative. Okay, so let's say I'm considering clockwise as our positive direction. Okay, so all that goes counterclockwise will be negative. So moment at point A, the first one, M because of point 1, because of the first one. Okay, the first one we get the angle, so like previous, I can resolve into two components, this one and this one, so I can erase this one. So this one P1, which is 10 cos 20, 10 sin 20, so I can erase this one. So because of the first one, put the pin here, I pull this direction, so it will go clockwise. So because of this one, it will be positive. So the moment is 10 cos 20, it is positive. And the distance you make a line on this force, which is line of action of force, and the second line perpendicular to this one, parallel to this one. Okay, second line parallel to this one and go through point A, so which is A here. Okay, so this is the distance, or by definition you have to find the perpendicular distance from A to this line, which is here 90 degree. The D is there. Okay, so the D is 1. Okay, and then this one, I put a pin here, pull that direction, so it tend to rotate counterclockwise. So now it becomes negative 10 sin 20. And the distance is, you make a line here, and the other line parallel to this one, we go through A, so this is the second line. So this is the distance, which is 2 meter. Okay, 2 meter. So what I always do is just, this is the force, so you make, this is the first line, you make a parallel, the other line here, this is the distance between these two, same as this one. You have this line and the other one here, so the distance is D. Okay, so this is 2. So finish for this one, we go to P2 plus 30, the D, the distance. Okay, now you have the pin here, you pull this direction. Okay, so you have pin here, you pull this direction, so this component will not rotate because of this one. Okay, so the moment because of this one will be 0. Or if you make a line of action of force, it will go straight to the point. Okay, so this one will be 0. P what? P3, same. This is the force. Make a line of action of force, you see that it goes through the point. This one also will be 0. So plus 100, 0. Okay, and then now P4, you make a pin here, push this direction, so we will turn clockwise. So plus 1, the distance is first line, second line here, and then this is the distance 0.5, and the last one is put a pin here, pulling that direction, so we turn counterclockwise, and negative 2, the distance, first line, second line on that point, so you have the distance, which is D, 1 meter, so 1. So you have, this is 0, 0, this one, minus this one, plus this, you have the answer, Newton meter. So this is how you calculate the moment because of several forces acting on the point. Okay, and one more thing is, the moment didn't depend on the shape of that component. What I mean by this one is, okay, so if I have this, actually, okay, this type of component, for example, oops, sorry, okay, higher, this one, okay, for example, I have this component, okay, so this is my point A, I have same, this is P5, and I have P3, P4, P1, so I should have one more here, okay, let's say I have this component, okay, like this one. Okay, so I have one more here. P2, even though the shape now is slightly different, okay, we don't have a cube like that. I mean, we have the component which is 2 meter times 1 meter, but we have this shape, for example. But as long as the distance here is same, 2, 1, 1, 1 here, 1 here, or here maybe we have 3 meter. As long as this distance is same, okay, you will still have the same moment from this, even though now the shape is different. Okay, because we only consider is the force times the distance, this force times the distance, this force times the distance. Whatever the shape is, as long as this force times the distance is respected, okay, and the direction is respected, so you have the moment. Okay.